Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up for two sample proportions, and all we're going to do in these are identify the important information. So a company wanted to evaluate whether using standard desks led to better workplace productivity compared to traditional desks. Employees were randomly assigned. All right, that's going to be super important. Randomly assigned tells us we don't have a condition two. A desk based on the last number of their employee ID. Those with an even number received a standing desk, while those with an odd number received a traditional desk. To ensure fairness, a coin was tossed to determine which group would receive standing desks. After 6 months, the company surveyed the managers of 400 employees. All right, that sounds like a sample size. And this is going to be who use standing desk. So I'm going to put an S for standing. And the managers of 390 who use traditional desk. So I'm going to go 390. And that looks like that's going to be my N for, and I'll put T for traditional. Now you can use N1 and N2, and that would be fine. The results showed that 210 standing desk users, so this is X for X standing, is 210, and 180 of the traditional, so 180 XT for traditional, exceeded productivity standards. All right. Construct a 90% confidence interval for the difference of proportion of employees who exceeded productivity standards for the two desk types. Well, we're not going to do that. All we're going to do is list and label the important information. I think we identified the important information. They're randomly assigned, and we have a sample size of 400 for the standard desk, which is what I'm going to go ahead and write down here. Standard sample size of 400, and we called that N1. It could have been NS. And we had 210 exceed productivity. All right. For the traditional, we had 180 exceed out of 390. That was our sample size. So if we go ahead and use our calculators, we can calculate our p hat 1. So in this case, it would be 210 divided by 400. Oops, 210 divided by 400, not 40. And we get 52.5. All right. And this is, and I'm going to go ahead and label this again. This is standard. Then on the traditional, we had 180 divided by 390, and that's 0.4615, and that is for traditional. Okay, moving right along to our next scenario. Losing it. Many fitness professors suggest that high protein diets are effective for weight loss, are more effective for weight loss than standard low protein diets, but is there scientific evidence to support the claim? A university research team from Stanford conducted a 5-year study on randomly selected individuals trying to lose weight. Participants were divided into two groups based on their dietary habits. Group A, and by the way, so they were divided, they were not randomly assigned, consisted of 3,850 individuals who followed a high protein diet, at least 30% calories, etc. So 3,850, that sounds important. Group B consisted of 3,100 individuals who followed a low protein. So we have, and these sound like sample sizes. So it sounds like I have a sample size for high protein of 3,850, and for group B, the low protein of 3,100. More than 5 million Americans are attempting to lose weight by following a high protein diet. Many more are following a low protein diet. Okay, so we have a population here of 5 million or more than 5 million. So it looks like that's our population size. At the end of the study, researchers recorded how many more are following, how many participants had lost at least 10% of their initial body weight. In a group, in group A, the high protein, 1,625. Okay, so this sounds like my X for the high protein. I'm going to put XH for high protein. I'm also going to take a moment and write 3,850 as my sample size and put an H for high protein, and 3,100, that's in, and that's going to be a low sample size for the low. Achieve this, while in group B, 1,210. So group B, 1,210, and this is going to be X for low protein. All right, so those are our two sizes. At alpha equal 0.05, do the data provide convincing statistical evidence that a high protein diet increases the probability of significant weight loss? All right, so we have, as we said, high protein, 1,625 lost weight, lost over 10% out of the 3,850. On the low protein, 1,210 out of the 3,100. And if we divide those out, we get the figures. All right. And so, and once again, I'm going to go ahead and label these P1. This is going to be high protein, and this is going to be low protein. All right. Now, we have to do a P hat C, and P hat C equals X1 plus X2 over N1 plus N2. So we have to add 1625 plus 1210, and we have to add 3,850 plus 3,100. Let's do that real quickly. So 1625 plus 1210. All right. And for the denominator, 3,850 plus 3,100. All right. So 2,835 divided by 6,950, and we end up getting 0.4079. So that's our P hat C. And we have to have P hat C for when we're running a hypothesis test. All right. Appreciate you watching. Hope that helps, and look forward to seeing you on the next one. Thank you.